In this video, we'll talk about the linear probability model. Now, remember that so far we've talked about binary or dummy variables that are introduced on the right-hand side. So they are actually explanatory variables that appear in our regression. But we haven't really spoken about what happens when our dependent variable, which is our y, is the cases where our y becomes a dummy variable. So there could be instances where we want to explain the outcome, whether it's a yes or a no, or a 0 or a 1 event, based on certain explanatory variables, whether those explanatory variables are dummies or quantitative variables that we're comfortable with. So examples could include, if you're thinking about our dependent variable being dummy, we could be interested in studying the question of a married woman's labor force participation. So whether married women participate in the labor force or not. Okay, so 1 for participation, yes, 0 for not or no. So Y could also be whether a firm files for bankruptcy or not, or whether a firm engages in a merger or acquisition or not. Or it could just be whether a young man is arrested for a crime or not, or a particular crime or not during a certain period of time. In each of these cases, the variable y is used to explain some sort of binary or dummy variable. Now we will focus on how we should interpret the population model when y is binary, specifically because y can only change from 0 to 1 or 1 to 0. So we will try to understand how do we make sense of the interpretation of these slope coefficients in our model. We will also discuss cases later in another video where we might encounter situations where y is actually discrete. So y may not just take 0, 1 values, but it could take any values that are greater than or equal to 0. And this could be, let's say, the number of arrests, or y could be the number of children, right? So we would not have any fractions. So this is specifically when y is discrete. Now remember that each time we are trying to predict the model, or we are trying to think about the expected value of y given x, we can write out our model in this form. So the expected value of y given x, and here the x in bold is representing all of your explanatory variables, x1 through xk, can be written in this form, right? After we understand the zero conditional mean assumption. So this would just tell us that the interpretation of a change in x, the interpretation of beta j would just mean that with a 1 unit change in x, there is some change in the expected value of y given x, okay? But this relationship is important when y is binary, or important for us to discuss when y is binary. So when y is binary, we're basically saying that the expected value of y given x is equal to some sort of a probability of y taking a value of 1 given x. And here we are talking about y equals 1 because this is a 0 or 1 event, or y is binary. So this is why the probability, since the expected value of y given x is just equal to the probability of y being equal to 1 given x, the probability itself is called the response probability. So we're basically saying that the probability of y equals 1 given x is basically equal to that same equation we had before. And therefore, the this type of a model is called a linear probability model, because the response of y is binary. Now, there are many other binary models like logit, probit, tobit models that are covered in detail in chapter 17 that you will see next semester. The other thing to remember is that all partial effects are effects on the probability that y is equal to 1. So sometimes we are interested in the probability of success of something, right? And that's what we're pretty much estimating. Okay, so beta hat j is basically measuring the change in the estimated probability of success when x changes by 1 unit, all other factors remaining fixed. And this is the interpretation that you want to focus on when using LPM, linear probability models. Okay, now remember that like in any regression application, you can have explanatory variable that appears in log, quadratic form, interactions, etc., as well as dummy variables.